All right. All right, friends. Time for an introduction to GitHub Actions. This one is going to be hands-on. I shared a GitHub repository in Discord. Make sure to clone that down, unless you're up to date from yesterday. If you're up to date from yesterday, you can just copy all your Terraform stuff into the backend project. Don't forget to include all the Terraform state stuff. Otherwise, you're going to have problems. But we're going to use all that today. And the presentation is going to be pretty short. And then we're going to spend the rest of the time banging our heads against the wall trying to get CI/CD to work, because that's how it always is. Setting up CI/CD is a pain, but we're going to have a good time with it. All right. All good? All right. Let's do it. So first, we're going to go over what even is GitHub Actions. We're going to cover what are workflows in GitHub Actions, and then what are jobs. We're going to talk about different run environments that are available, followed by secret management, which is absolutely critical for the deployment side of things. And then we're going to talk about external actions, because that's just way easier than doing everything yourself. And we're going to end talking about artifacts. Sound good? All right. As usual, I've not written a book on this stuff. I use it a bunch. You get the idea by this point. So what is GitHub Actions? What are GitHub Actions? It's weird because actions is plural, but it's a name, so it should be singular. Whatever. In short, it's a continuous integration and continuous delivery or deployment platform. It is integrated with GitHub. So when you push stuff to GitHub, stuff happens. It reacts to Git events. So, push, tag, all these different events you can configure it for. It's also highly configurable. You can do all sorts of stuff. If you can describe it with a bash script, you can do it with GitHub Actions. And it also has various environment configurations you can do. And you can even do like multiplicative operations. So let's say you want to run it for like 10 different Python versions or something. You can do that. Also, it supports cloud or on-premise. It does provide some kind of hidden cloud compute for you, or you can configure it to run in your data center if your systems need some kind of special network access, like we do. And it does have a limited free use option. So you get some number of hours of GitHub Action time using the cloud compute for free. And the cost is pretty good. The free allowance is actually quite generous, unless you're using Mac runners. Those get really expensive real quick. But usually, like, who's deploying to Mac, right? It's usually only for like desktop systems. So if you're doing backend stuff, you don't have to worry about that, unless you're using Mac servers. But then why? Anyway, so does that make sense so far for kind of a high-level overview of what GitHub Actions is? Okay, I'm trying to go fast because we need a lot of time for the hands-on part. So what is a workflow? First off, it's all written in YAML. Okay, it's just a big giant YAML file. And really, it's just a series of jobs. So the workflow, it's basically just a way to organize your jobs. It's just a file. It's a file. It's just a way to organize your jobs. You can have one file, you can have multiple files. Most people just have one file unless there's really, truly, completely workloads, in which case they'll separate it into multiple. Often for smaller projects, you'll just have one workflow file and it's fine. But it does define triggers, right? So everything, if you need different actions to be triggered by different events, you do want those in separate workflows. And it allows you to define various configurations, which we'll talk about. That's more at the job layer, but yeah, we'll talk about that a little bit more. Now, do note that you don't have to do only CI/CD with this. You will come to find that as you look at CI and CD systems, they're all just task runners. Everything's a damn task runner. Like, you could do anything with it. You could theoretically build a data pipeline with GitHub Actions. Don't do it. It's a terrible idea because it's not built for that, and there's a whole bunch of additional problems. But in the end, it's just a big giant task runner. Most of the time, you want to use it for CI/CD. but sometimes you can use it for things like documentation generation or documentation site deployment, which is technically CD, I guess, but you get the idea. And that's quite common too. You'll see a lot of documentation generation in GitHub Actions as well. You could argue that that's part of continuous integration, but yeah, depends on where you draw your lines. So does that all make sense so far? Cool. Again, this is just conceptual. I'm going to demonstrate this with actual code in a few minutes. And then jobs. Jobs are where the actual work happens. Okay, you can have multiple jobs in a single workflow. They're just a series of steps. They are ordered. And the big thing is that a job runs on one runner. So you have a job and then you have various steps that the job does. You can have multiple jobs in one workflow, and each of those jobs can run in a different runner. A runner is basically a computer, usually a Docker image, okay? Unless you're doing on-premise stuff. Now, this is important because maybe you need to run in different versions of Ubuntu or something, right? Or maybe you need to run on Ubuntu and Fedora, or Ubuntu and CentOS. Or maybe you need to run on Mac and Linux or whatever. And in this way, you can kind of split your jobs on running on different machines. And the big thing is that they can be matrixed and multiplied, like I said earlier. So you can say, hey, I have a set of like different Python versions. I want to run all the steps on this job with all the different Python versions. Or I have these configurations. I want to run it with this set of configurations and this set of and this other set of configurations with the same steps and the same steps on another set of configurations, so on and so forth. Okay. So it's really nice to get really comprehensive integration testing with minimal effort. So yeah. And then there are run environments. These are in GitHub Actions, we call them runners. They're either Docker container images, they're either Docker images that it will spin up containers on and run your jobs in that container. Or if you're doing an on-prem runner, they call it a self-hosted runner. If you're doing a self-hosted runner, it can just be on whatever computer that is. So let's say you're doing machine learning stuff, and your machine learning model, you need to test that it behaves the same on a whole bunch of different GPU architectures. Well, you probably have a data center with all these different GPU servers, and you can basically configure all those different GPU servers to be GitHub Actions runners. And then when you push your code to GitHub and you trigger your CI, it can push your workflows to all the different servers that you have on premise, and you can test your code with all those different CPU architectures. Surprise, that's something we do at Lunit as well. So that kind of stuff is very useful. So it is important to understand the different run environments. Now, when you do the self-hosted runner, you can either just run on the server directly, or you can run in a Docker container on the server. All this stuff is configurable. But generally, your run environments are containerized. That's just good practice generally. We should be Dockerizing everything these days. And there are other considerations for GitHub hosted versus on-premise, right? So for on-premise, if you have any sensitive data systems, right? So let's say you're in a high regulatory environment and there's certain data that you need to be able to access to run your integration tests. You're probably going to want to use an on-premise runner so that it can be in the correct network to access whatever sensitive data you have, okay? With a GitHub hosted runner, you can't do that, right? GitHub does post a list of public IP addresses for their runners. If you want to have if you have a system that you want to allow public internet access for a whitelist of IP addresses, and then you can just whitelist GitHub's IP addresses for their runners, but I'd rather just do on-premise. Less risk, less security risk if you just do it all on-site. And then the runners are customizable. So if I recall correctly, I think you can specify your own Docker images to run on the GitHub hosted stuff. If I remember correctly, I should have checked, but yeah, it's something to look into if you think that could be useful. And the nice part is, let's say you're in a big organization and you have some GitHub hosted runners using special Docker images, some default GitHub runners, some on-premise GitHub runners. but you don't want everyone in your organization to be able to use them, you can give permissions to different repositories to use different runners. So for example, if we go back to that GPU example where you have a bunch of GPU servers, you don't need your backend web application that doesn't need a GPU to be running on those runners, right? Those runners, they only have so much compute, they only have so much capacity. So you can whitelist only your machine learning repositories to access those runners with those GPUs, right? So in this way, you can kind of manage your resources and make sure that someone who messed up their testing and their tests take an hour to run doesn't monopolize a really important runner that you need for another repository. Does that make sense? Cool. All right. And then secret management. This is super important because when you do continuous delivery, continuous deployment, whatever the hell we're calling it, not just anyone or anything can deploy to your production environment, right? You need some kind of access control, some kind of login to actually update the code in your production environment. GitHub is another company with another system that is not integrated with your system. They cannot automatically access your secret shit, okay? So they allow you to configure secrets in GitHub Actions as environment variables that GitHub Actions can then use to log into your deployment systems and do deployment, okay? It's a very simple concept. But one thing to be careful of, the GitHub Actions jobs, anything printed to standard out gets logged. So if you're trying to debug your GitHub Actions configuration, don't print out your secrets because then they will be in the logs, which anyone with access to that repository can see, okay? Do not print your secrets. Do not print your secrets. What should you not do? Perfect. Thank you. Don't print your secrets. You're going to have a bad time. I will find you. Not really. All right. So all good on the secret management stuff? Cool. The funny part is when I give these kind of presentations in the company I'm at, and I tell them hey, don't do this thing. It's a security risk. And I say, I will find you. People actually do get scared because I have gone up to I went up to a VP one point because he did some code stuff and he just threw some stuff together that was wildly insecure. And I'm like, so that commit yesterday at 3:42 p.m. What you doing, bud? Yeah. It's kind of fun to be that guy in your organization because who's going to get mad at you? You're keeping the company secure. Anyway, okay, enough shits and giggles. And then external actions are a big thing. So at this point, everyone and their mother has written a GitHub action, okay? And it's very rare that you'll need to write your own custom actions, okay? GitHub Actions has this marketplace. I'm just going to go ahead and click this link here. And there's a whole bunch of stuff like build and push Docker images. Surprise, we're going to use that one. So you don't actually need to write the whole script yourself. You can just choose this, and then you can just go to their documentation and be like, okay, so I just say, I want to do a build push action. I want to push. Here's the tag I want to apply. Done, right? You don't need to write any actual code, just a little bit of configuration of the action, right? Again, we want to do stuff as quickly as possible. So why would we write our own code when someone has written the code to do exactly what we need? Now, one thing to be careful of, though, when you use external actions, right? First off, make sure they're from a trusted source, okay? And make sure that, pretty much all actions are open source. So if you can spare the time, and you really should, check that source and make sure it's not sending your data off to sketchy hacker 01 at torserver.net or something. I don't know. Because when you're running other people's code on your systems, little bit dangerous. So make sure to check this stuff. But to that end, you can pin a specific version or even a commit of a GitHub action so that you can make sure that the code that you checked is the code that gets run. Because if you just say, oh, let me just use the latest version of this action, and then someone gets access to that action's repository and then, you know, alters that action to send data to the CCP or some shit, right? Like, that would be bad, okay? So make sure that you pin the version of the action you're using. I recommend pinning versions quite strongly. Ideally, unless if it's a non-trusted entity, like if it's not someone like GitHub or Docker or whatever, like pin the very specific version or even pin the commit. Otherwise, if it's a trusted entity like GitHub or something, you just pin the major version number and it's probably fine. Okay. And the nice part is that it basically makes your GitHub actions composable. You just be like, I'm going to use this action, I'm going to use that action, I'm going to use that action, do a little bit of configuration, I'm done. That's the ideal, right? We don't want to reinvent the wheel. So does that make sense for external actions? Great. Oh man, we are tight on time. This is going to suck. And last thing I want to cover is artifacts. If you have kind of intermediate build artifacts, like for example, let's say that you're using a compiled language like Golang, and maybe you want to produce a bunch of different binaries and then do something with all those binaries at once. What you can do is you can do your matrix jobs where you can run it for like all the different versions that you need to produce binaries for. You can store those binaries as artifacts on GitHub's servers, and you can set a retention period for them. And then in your next step of your workflows, you can, or in the next job of your workflow, sorry, you can just pick up those artifacts and do whatever the next step is, okay? So artifacts are basically intermediate storage. They're build artifacts, really. If you're doing stuff like interpreted systems like Python, it's less useful. But if you're doing things like compiled languages, you're going to use this a lot. The artifacts are transferable between workflows if you need. There is limited storage, but like it's just to make sure that you're not using the artifact server as like your personal image CDN or something like that. The storage should be more than enough. And you can set a retention policy so that you make sure to not fill up your storage. So, you know, if it's a build artifact, you don't need it more than like a day or two at the worst case. So you usually just set a retention policy of like a week or something and you're good. Okay, does that make sense? Great. Any questions about the concepts for GitHub Actions? Yes.
I don't quite understand the pinning concept. I mean, what do you actually pin? Do you pin your code version or do you pin GitHub Actions themselves?
You pin the version of the external GitHub action that you're using. So if I have some action, do really cool thing, right? In your GitHub Actions configuration, when you use the action that I created, you basically import and use my action. You can say, I want to use really cool thing that I created version 3. Yeah. Thank you for asking for clarification. Any other questions? Yes.
What about? I was wondering about GitLab because it has also a thing similar GitLab we call it like quick action.
Yep.
And you can also install it in your local server. And so actually, I was just wondering what your opinion was about that kind of solution.
Yeah, so GitLab CI, I actually really like GitLab CI. I think it's, in terms of usage, I think it's my favorite CI system. Just setting it up and deploying it sucks because GitLab is very, very heavy. But it operates in the same general principles. If I recall correctly, I believe GitHub or GitLab also has kind of actions that you can just import. But the concept is the same. You can have runners running on the GitLab server. You can have external runners. There is secret management. It all works the same. It's the same general idea. Most of the CI/CD systems work very similarly. Like once you get familiar with GitHub Actions, you can go over to GitLab CI and just be like, yeah, okay, I know what this is. Yeah, so it should be a trivial cutover. There'll be a couple of little things that you'll want to check, like they do a couple of their environment variables a little bit differently than GitHub Actions does, if I remember correctly. But most things are largely the same. Does that answer your question? Great. Any other questions? All right, who's ready for absolute chaos? All right. So I have tested this on my machine, but you don't have my machine, right? So this is going to be great. What could possibly go wrong? What could possibly go wrong? Okay, so wait. No. Crap. Give me 1 second. Already, we're off to a great start. I just need to, when we do this together, we should be using a clean version of the repository, not the final complete version I have, but I need to reference the final complete version to make sure I don't do mistakes. So I need to get 2 copies of it going here. Give me just a second, guys. Oh, come on. What? What do you mean cannot read from? Ah, we'll do this. Okay. There we go. Okay. There we go. There we go. All right. Excellent. So, I have here the repository as it currently is in GitHub for the backend project. Okay. I updated it like an hour ago. So if you do not have this project, or you haven't been here for the previous days, go onto Discord, clone this one down. We're going to base our stuff off of this. If you've been here for the previous days, you want to copy all the Terraform stuff from the Terraform stuff yesterday into your backend project, okay? Because we want all this stuff to just be in one place. So I'm gonna walk through how to get this going, and yeah, it's gonna be rough. Tom, can you do me a favor and just run outside and grab whatever people are able and willing to help, because we're gonna need them. So previously we set up this why oh I'm sorry, one second. This is not the original version. God damn it. There we go. Okay, much better. All right, so yeah, it's fine, I'll fix it later. So your Terraform should look something like this, right? Yesterday we had but I made some changes because I'm too picky about shit. Okay, first off, I use the newer Terraform, the newer version of the Azure provider. Okay, you don't have to do that, but if you run into issues, you may want to update it. But if you do that, you need your environment variable. Okay, so I made a .env file. Okay, and I put my subscription ID in there. Okay, if you don't know how to get your subscription ID, You can do, is it okay for this? Yeah, it should be fine. You can do AZ account show. I hope there's nothing secret in here, but yeah, it's fine. Yeah, the internet can know all my secrets. What could possibly go wrong? Your subscription ID is here if you're not familiar. If you do AZ account show, okay? So AZ account show, and the ID is your subscription ID, okay? And make an environment variable with that subscription ID. Make a dot. I usually create a .env file, and then I toss this in there, right? I created this template file that you could just copy and rename it to .env, and then paste your subscription ID in there, and you're good, okay? So give everyone a second to do that if you're following along. So AZ account show to get your subscription ID, copy your env template. Actually, yeah, I can just do this with you because, you know, my thing's already out there on the internet. What am I doing? So we can copy, come on. Okay. We can copy .env template to .env, and then I can do AZ account show. I can copy this ID here. I can open up my .env, and I can paste that ID here. Yeah. Done. Okay, everyone's there? Great. So now, if you're make sure your Terraform provider is the up-to-date version. 4.16 is the current version. Okay. You will have to do a Terraform init upgrade. Okay. You'll have to run this guy down here at the bottom because we changed the Terraform version. So it has to download, or we changed the provider version, so it has to download the new provider. Okay. So far, so good. Bam. I already downloaded it, so yeah. Then, if you cloned down this project, make sure to change your web app name. Your web app name must be globally unique, like globally, like on planet Earth, okay? So put something like your name and then a couple numbers or some shit, okay? Actually, probably no one else is going to have the prefix, so you can just put your name. But make sure to change that. Okay? All good? All right, now we're going to get into the nasty stuff. So, crap, I should have written down the order. Wait, I did. There it is. Okay, great. So now, if you have not already, go ahead and do a Terraform apply, okay, to make sure that all your stuff is deployed. Do you need help?
We copied the last day's Terraform state files to.
Yes. Yeah. If you followed along yesterday, make sure you copy your Terraform state files as well. Otherwise, you'll try to redeploy the same thing and it'll fail. If you copy the state files over, it'll recognize that that stuff is already deployed and it'll basically be the same state. Okay. So make sure to copy your TF state file and your .terraform folder. Okay. All right, we're gonna get to the nasty stuff soon, guys. So be ready. All right. So now. Oh. Well, why didn't I do that? Yeah, whatever. It's fine. So now we're gonna do a bunch of stuff. Okay. First off, we want to deploy. Yeah, let's do it that way. We want to deploy our own Docker image, right? We don't want to deploy Nginx anymore. We want to deploy our own. Okay. So to do that, we need a new Terraform resource. Okay. By the way, for those following along online or people who are not here for Terraform, you might want to go catch up on that stuff. But let's define a new Terraform resource. Okay. we're going to define an Azure RM container registry. Azure RM container registry. Okay. And I'm just going to call it a registry for now. And this registry, remember learning about Docker Hub? This registry is our own Docker Hub. Okay. It's our own private Docker Hub in Azure. And then what we can do is we need to give it a name. So I'm just going to call mine Bootcamp, or I called mine Bootcamp. You probably want to give it a different name. I'm not sure if they need to be globally unique or not. I think they do. So give it some kind of, actually, there's no way. No, because it's in a resource group, so it should be fine. But in any case, yeah, give it some kind of name. And then you want to set the resource group name to the resource group we have above. So we can just do that. And we want to set the location to the same thing, the Azure resource group dot location. Oops, I forgot the name here. Sorry. Okay, so all the autocomplete stuff. And then we need to give it a SKU, basically which kind of registry we want to do. We don't have all the money, so we're just going to use the basic registry. And then we want the admin account enabled. Now, you may not want to do it this way in actual production, but we're just trying to get stuff running for now, okay? So let me know when you guys have this. And after this, we're going to do an apply, and then everything's going to break. It's going to be great.
Terraform upgrade common.
What kind of error you got? Because people are still going to be typing that.
Terraform init space dash upgrade. Yep. Space dash upgrade. Upgrade.
Sorry? We do the apply after this. Yeah, so wait a moment on the apply. So now once you have this, you can go ahead and hit apply. Right, sorry. Don't hit apply yet. Terraform init, you might hit an error. I'm actually not sure if you will. You want to source your .env file. That's why we made it, because with the new provider, we have to give Terraform our subscription ID. And yeah, we have to give Terraform our Azure subscription ID. So by sourcing that env file where we put our subscription ID, we can get that. So we can do source.env and Terraform apply, and then we should be good. Okay? Ready? Here we go. Oh, it's going to destroy all my shit, isn't it? It'll be fine. And this takes a minute because Azure is slow. Or at least it's being slow for me. Maybe it'll be fast. I don't know. Let's see. Okay, so what this is going to do, again, this is going to create our own container registry that we will push our Docker container to, or a Docker image to. All right, so this is going to take a minute to run, so I'm just going to leave it. All right, while that's running, create a new directory. Oh, right. Create a new directory, .github/workflows. Okay. And then in that directory, create a new file, workflow.yaml. Oh, that was fast. Okay, so I can just type yes here, and everything will be deploying. I probably should have checked this before typing yes. Yes, I'm going to break my stuff. Yes, that's okay. And then I would type yes. Don't type yes before checking that stuff, but we're just trying to go fast. Okay. So we have this workflow.yaml file. Okay. This file is what is going to do all of the fancy stuff. Okay. 20 minutes. Let's do this. So what I'm about to do is not good. Okay? Don't do it exactly the way I'm doing. I'm going to say, what in a GitHub workflow, you have to tell it when we want the workflow to run in response to what Git event. In this case, I'm going to say on push. Do not do this in real life. Okay? For this thing, it's fine. But you don't want to trigger your GitHub actions on every single push normally. You want to trigger it on a merge, or you want to trigger it on push to a specific branch or something like that. Okay? This will configure it to go on every single push. And that's because I'm in a hurry. Okay? Don't do that normally. So now we're going to give our workflow a name. I'm going to call it build and deploy. Also, let me make this a little bit bigger because I'm not sure everyone can see it. Okay, great. My changes happened. All good. If anyone hits an error on their Terraform, start. Yeah? Okay. Can someone help them out? And helpers, I know you may not necessarily be well equipped for this. So if you have trouble helping, call it out.
I think Bootcamp should be globally.
Okay. Thank you. So guys, if you hit an error where it says this already exists, make this globally unique. Do bootcamp dash your name or something like that. Okay. Also, I'm surprised that no one was using bootcamp already. That is surprising. Anyway, yeah, change this to bootcamp something unique. Okay. Thank you. All right. So once you've got that going, let's go back to our workflow. And I'm going to create our job. I'm just going to create one job called build and deploy. And I'm going to say that this job runs on the latest version of Ubuntu, because I don't really care. I just need some Linux environment. And I'm going to just say that the environment is production. Okay. In reality, it's not. And you shouldn't just by default call stuff production. But there is a reason I'm... Actually, I changed the way things work. So yeah, we actually don't need that, I think. So never mind. And then we start on our steps, the actual main part of our GitHub GitHub action. Okay. So first thing we need to do is we need to actually check out our code. Okay. Because when GitHub action starts, it's just going to create an Ubuntu container, and that's it. It doesn't know or do anything else. So we have to tell it, hey, actually check out our code. So we can use the GitHub actions organization, the checkout action. And this will check out our GitHub repository. Okay. It just does a git clone to get our code into the container that's running the GitHub action. Okay. And then actually, let's just who still needs help with Terraform stuff? Yeah. Okay.
Uh-oh, we got two people. Tom, can you help her or no? You're not sure either? Okay. What you got? Oh. What region do you have? Yeah. Okay.
So guys, if you're encountering issues with like quota stuff, in the version that I have here, I switched the location to Korea South because I thought that would be faster, because then you're hitting local servers rather than going over to Europe. However, if you're getting issues where it says 0 instances available in the quota, change it to West Europe or something like that. Okay. Sorry about that, guys. I didn't expect that. It's really strange. Habibo, do you still need help? Yeah. Infrastructure is always fun, right, guys? All right, who's still having trouble?
Yeah.
Oh, the workflow or this? Down here? Remember that this should be a unique name. The container registry name needs to be unique.
Like, well,
I think so. Yes. So the .env should be quite simple. Whoa, 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 wrong one. Yeah, come on. Yeah, there we go. Wait, what the hell? Oh. You just need the something like this. And then make sure when you do your Terraform apply, you should be doing source.env and Terraform apply. All good? No? What you got?
I need to do that.
All right. Who else is having trouble? Still? Boy, yeah. Okay. Maybe I should start with Emmer's version. I got the same one these guys. When you did the actually try applying again.
But I don't do it.
Can I see? Okay, how would you? I'll just do a Terraform restore, and then apply again. This has now become a Terraform session. All right, friends. So if you're still having trouble with Terraform, let's just hold off on the Terraform stuff for now, and then I'll go and run around and help everyone all at once. I want to make sure we get through the GitHub action stuff so that you understand that, and then we can troubleshoot the Terraform side of things to get it to work. By the end of this, the goal is to have it so that your backend server that you built is deployed on Azure. This is like the big one. So we might cut into lunch a little bit, and if we have to push other stuff back, that's totally fine, okay? Because it's important that we get this one working. This is like the big one for you guys. So let's go ahead and go to our workflow. Even if your Terraform's still acting up, just leave it broken for now, okay? And you should have this kind of stuff in your workflow file. And after this, we're going to do name, image, no, sorry, Docker login, because we have to log into that registry that we're going to create with Terraform. Okay. And then we want to, rather than do all the Docker login stuff ourselves, Azure has published a Docker login action that we can just use. So let's go ahead and use that. And then it has some configuration that's needed. So that configuration, we need to give it the login server. Not servers, secrets. Secrets. There we go. And then we need to give it a username. Ugh. And we need to give it a password. Ah. Now, that $ curly bracket, that's basically using a variable in GitHub Actions, okay? And then in GitHub Actions, the secrets object stores all of the secrets that we configure in the GitHub repository, which we're going to do after we finish this part, okay? So there's not magic going, or I mean, there's a tiny bit of magic going on here, but I'm going to help it make a little more sense afterwards. So take a moment to get all this copied down. Sure. Sorry, guys. There we go. Better? Is this big enough for people to read? Do you need it to be bigger, or is it okay? Seems okay. So again, on every push, we're going to run this build and deploy workflow. We have one job in the workflow called build and deploy. This job is going to run on a Docker container hosted by GitHub. It's going to run the latest Ubuntu image that's available. And then the first step, we're going to check out the repository, okay? And then the second step is going to be to log into the Azure container registry that we're trying to set up with Terraform, okay? So has everyone got this typed down? I see a couple people still typing, but I'm going to move forward and you can just catch up, okay? So next up, we want to actually build our Docker image and we want to push it. So we're gonna create a new action called build and put, or image build and push, or sorry, a new step called image build and push. And this is going to use the Docker build and push version 5. They've done a lot of work on it. And we do want to do a push. And we want to tag that image with our container registry server name. And then we want to name the image. I'm just going to name it e-commerce because we're making what's supposed to be an e-commerce app. It's just a broken piece of shit, but whatever, it's fine. And then we have to give it a tag. Now we want to force a redeploy every time, okay? So if we just use the latest tag, it's going to be like, oh, it's the same tag, so I don't need to redeploy. So instead, we want to tag it with the commit hash. So this will build a Docker image using our Docker file here, okay? And then it will tag it with our registry server / e-commerce with the image tag version being the commit of the repository that we're currently on, okay? Does that make sense? And by having that commit hash rather than just the latest tag, that will force it to deploy the new version because it will see that the image tag is different. Okay? People still catching up? Okay. And now here comes the magic. Whoa, hello, caps lock. We're going to actually deploy it. So we're going to use our Azure Web Apps, okay, because we deployed an Azure Web App. And we're going to configure it. Give it the app name that you used in your Terraform configuration, okay? So in this case, I'm going to call it example web app CodeSeoul Beach. You can call it whatever you this should match what you have in your Terraform for the Linux web app, okay? And then the image is going to be basically the same as here. I can just copy and paste this. We want to push the image we just built. I'm sorry, we want to deploy the image we just built and pushed. And then there's this idea of a published profile. We're going to cover that in a couple minutes. I like having my terminating new line. Okay, there we go. All right, so I'll give everyone a minute to catch up on this. I'm sorry, guys, we're going to cut into lunchtime a little bit, but we have a longer lunch today, so it should be fine. What's up?
Oh, actually, that's I don't think that's service.
All right, so has everyone got this typed out? How's it called? Yeah, service plan. Search for service plan. Maybe? Yeah, what's up?
Are the one that want to reach the big, but are they below with you think this thing was
Yes. Oh, actually, yeah, sorry, you're right, you're right. What I have up here is wrong. Sorry, guys. I have an extra indentation where I shouldn't. And then I'll get to you, Dennis. There we go. Sorry about that, guys. What's up?
Or was that it? Oh, shit. Everyone's sitting that. Yeah. Yeah, so, okay. So guys.
Emergency.
Yeah, so.
So guys, I apologize. Yeah, I'm gonna. So if you're stuck on your Terraform destroy, or if you ran it for 5 minutes and nothing happened, first off, I apologize. I probably shouldn't have changed Emide's stuff, but the chances are you got to go into the UI and just destroy it that way because it's all messed up. So what you can do, you go to portal.azure.com. Don't make me log in, please. Please don't make me log in. Please don't make me log in. Thank you. And you can go to your service group, or sorry, your resource group, resource groups, and just delete it. Okay. So you can check and hit delete. Where is it? Wait, where the hell? Or I guess open it. And then, yeah, you can open it and then you can check your example service plan and you can delete that. Okay. Or you can probably delete, yeah, delete the app service plan and delete the app service, basically delete everything in here. Okay. And then once that is done, interesting. Interesting. Huh. You might need to change the name of your resource group. Yeah, because what happened is the resource group you create, actually that doesn't make sense either. In any case, just try to delete everything and then do a Terraform apply. If it doesn't work then, it should be okay. Or if it, sorry, after that it should work. There we go. So, because what we have is we have the example resources and we have the service plan. The only problem is I don't see a way to delete the resource group. So if, you can do delete resource group here. There it is. Okay. It still doesn't work.
Type delete down here, or enter the resource group name. So enter example resources. Yeah, there you go. And then resource groups. Yeah. So go ahead and go in. Resource. Yeah, so it's not.
All right. So if you do that delete resource group, it should just nuke everything. Okay. And then you can do Terraform apply and then everything should work. Yeah? No?
And whenever I have to fuck with everything. Yeah. In that case, maybe delete the Terraform script. Delete these two down.
If after you delete that stuff, the Terraform complains about resource not found, just delete your Terraform state. Yeah, what's up? After the YAML? Yes. So folks, let's take a pause from the Terraform stuff. Okay. Is everyone up to date on the workflow? Yeah. Of the workflow? Yeah, you don't forget the space here. Okay. All right. So now we defined all these secrets, right? Right. That's why we did the Terraform stuff. So yeah, we actually have to get the Terraform stuff working before we can do this part. So who's still having Terraform issues? Okay.
Terraform, it's been creating for like 20 minutes now.
Creating?
Still creating for like 20 minutes. That's weird. Now that there's already started. Yeah. Now, one.
All right. Who else having Terraform issues? All right. Anyone else? So now do it. So everything is clean. Your Azure is empty. Right. Okay, great. Then do a Terraform comply. So source stop env and Terraform. Delete the state files. State files. Let's do keep the log. So let's do source.env and Terraform.
Which,
Yeah.
could we get this workflow YAML file in general channel
Yes.
just to
Yes.
paste it?
Yes. Yes. Yeah, I should do like I'm gonna. Can I do that? Okay. The hell? There we go. All right, everyone is good?
Which files should they do?
The TM state file, so these two.
All right, what's on like?
After the lead.
Yeah.
Ah. I know, that's fine. So do a Terraform refresh. For source.env and then Terraform refresh. All right, who else still having issues? Source. You should be using Github. All right, who else? Going over here. Oh. I see you're done your feet. Ah. Here. So that backs on Taurus. That's Windows, Windows UI, Windows character front, and then so those two characters, Windows. Linux should make a bunch of characters. Is that just what happens is when you're on Linux, trying to use the UI, Linux doesn't recognize the character for as a new character, just recognizes it's represented by that. Yeah, that's why Linux and Windows don't play nice. Yes. Yes, at least I did. Yes. Now delete, or actually, yeah, you're good. So now do Terraform apply, or do the source.env and then Terraform apply. Okay. 12 seasons, yep. Yeah, how do you? Try Terraform. Okay. Man, fuck out of here. Okay. So what's happening, guys, is something is weird with the Azure provider where it's not syncing resources correctly. What's happening is it's sending the request to create the resources to Azure. Azure is creating them, but for some reason, the Terraform provider is not able to find those resources after Azure creates them. So it's like, please create this. And then it's like, okay, I'm waiting to see the created version of it. And it waits and waits, it keeps pulling Azure, and then it doesn't find it. It seems to be a bug in the Terraform provider because, yay, Microsoft. What's up, Tom? It seems so. But in any case, people who are encountering that inconsistency error, like if you look in the portal, the resources exist. So the stuff was created. Now, this is not a proper way to do Terraform where it's like, oh, it's created, so I don't care. Like, no, you want the Terraform state to be matched up. But for now, we're just going to run with it because I don't want to take up too much of the lunchtime. What's up?
I was actually trying to add the transform statement.
Okay.
Because there are some like resources that should be created before and after.
Yes.
So I think if we fix that, the ordering side, then it should work because that usually like the problem.
So yeah, so we had a comment that maybe if we add depends on, it should fix things. But the issue is when you do this kind of reference here, when you reference one resource inside another resource, that creates a depends on. So you can try it. Maybe the provider is written super badly and maybe it won't work, but I'm pretty sure that's a Terraform level thing, not a provider thing. So yeah. Anyway, there is another change we need to make. In our web app, we need to, in the application configuration here, we want to pull the Docker image that we push to our container registry, okay? The problem is our container registry is private, so that will not work. We need to tell the web app how to log into our container registry to pull the information. To do that, we're going to change some stuff here. So I'm going to name the image Bootcamp. This does not have to be unique, okay? Because this is local to your container registry. And I'm going to change this URL. I'm going to do some string interpolation here. And I'm going to say, let's use the container registry that we made. And let's use the login server here. And that will be our Docker registry. Okay, so we're going to use the registry that we created to grab the Docker image for our web app. And then we need to provide it the username and we need to provide the password. And fortunately, we can just reference it. We can just say, hey, from the registry, just get the admin username. And from the registry, just get the admin password. Easy, right? So go ahead and make sure that this application stack block, whoa. Make sure this application stack block matches what I have up here. And then there's one more change we need to make. After our app settings here, it doesn't have to be, actually, yeah, it should be after your app settings here. We need to add a lifecycle block. And we want to say ignore changes for site config 0, application stack 0, and the Docker image name. Okay, because what happens is we're going to use this Bootcamp latest image for our first deployment. Okay, but after that, we're going to deploy from GitHub Actions, right? And if we do a Terraform apply later, we don't want to revert to some old image, right? We want to leave whatever the image is that GitHub Actions is placed. So in Terraform, we can say, hey, ignore changes to the Docker image name. because GitHub Actions is going to mess with that. Okay. Now we have to tell it it's in the site configuration in the application stack. We have to add that bracket 0 because you can have multiple site configurations and you can have multiple application stacks. So you have to say, hey, use the first one. Okay. So make your Terraform match this here. I don't know if it'll work because it's going to try to sync the state first and that's going to fail and then it won't let you create, but we're going to try it. Let's see what happens. If it's working now, then yeah, just add this stuff and apply. So give everyone a minute to type this up. And then we only have one more step after this, or technically 2 more. Or 3 more if we want to make it nice. And one of them is really easy, so it's fine. Yeah. Here, I'll share. Sure. Here, guys, to save you some typing, here's the Terraform. Just copy paste that whole thing. Or not the whole thing, sorry. You want to change your, make sure that your app name and your registry name are your custom global unique ones. Okay? Yeah, sorry, Sam, we're running a bit long. Okay. So everyone take a minute to get that stuff copied in there. And then once you have that, I do recommend adding some stuff to your Docker ignore. Oh crap, did I not add it in? Yeah, let me add it here. So you should put your TF state in here. You should put your .terraform in here. You should put your rough cache, I think was missing. Sorry, I forgot to include this in the GitHub, in the Git version. The .env and the .env template. None of those need to be in your Docker image. So we can just add those. And oh, and all of our Terraform files. All of our Terraform files do not belong in Docker. Oh, and the GitHub directory. So yeah, and .docker ignore. And then if you're, if you copied from, oh, and then we should also add our Terraform stuff in here. We should not include the .terraform directory and we should not include the TF state files in our GitHub. And then add these to .git ignore. Thank you. Yeah, that would be better. Yeah. Yeah. Thank you, whoever showed that. Okay, so once you have those, we just have a couple steps left. Okay. So here, look back up here, guys, because we got some stuff we need to do in the UI. So go to your GitHub repository, the one that you're doing this on. Ah, shit. I should have advised you guys to fork instead of just clone. Yeah. Oh well, you can just fork the repository and then change your remote, and that should be fine. So if we go to our repository, go to your repository settings, okay? And then you want to go down to secrets and variables. And then actions. Okay? And you want to add some of these. You want to add the registry login server, the registry password, and the registry username. To get these, in Azure, you can go to your Bootcamp container registry. And you can go to, crap, I don't remember where it is now. Where is it? Is it identity? I don't remember. Nope, not identity. Maybe. There we go. Thank you. Yeah. So in the Azure portal, you can go to Bootcamp, you can go to access keys. Okay. And you can grab your username here. And you want to make a new repository secret. And you want to call it registry username. And you want to copy that into here. Okay. And then you want to create a registry password. And you want to click show here, and you want to copy and paste that. Okay? Sorry. So in your repository, go to settings, secrets and variables, actions. Okay? Click new. And then we need to do registry username, registry password, and registry login server. These are the variables that we referenced in our in our workflow.yaml. Okay, so these. Okay, let me take a look in just a second. And then get the login server from here. Okay? Let me come take a look at yours. By doing stuff lots. Normally I would not be so confident, but I tested it myself earlier, and I have not touched that hard at all. All right. So once you have that done, assuming all the Terraform stuff is good, you should be able to commit your changes. Okay. So where's my, let me just go over here. My final version has, I'm matched up with our final version right now. We don't need the outputs. I don't know why I have that in there. But you should be able to, let me go ahead and delete my outputs here. Let me delete this file because we're not using it. Git status, git add outputs. Okay. And then what we can do is I can commit this change. And then once you have made your commit, you can push. Oh, wait, no, I'm sorry. No, I missed an important step. Back in, there's one more thing we need to do. Back in Azure, your web app here, okay, go to your web app in Azure. And you'll see this download publish profile, okay? Go ahead and click that. Okay, and it'll download an XML file. And if you pop this into your VS Code, It's basically just a giant blob of XML. Okay. You want to copy this because this is how GitHub Actions is going to log in to Azure to update your web deployment. Okay. And you want to go to your GitHub Actions. You want to create this Azure Web Publish profile. Okay. Again, this is another variable in our GitHub Actions. So you want to click New Secret, Azure Web Publish profile, and you want to paste. It's going to be a big, crazy, long thing. Okay. And you want to add secret. Now, once you have that done, you should have these 4 repository secrets. So what'll happen is your GitHub Actions will use these to log into the Azure Container Registry. And then it will use this to update your web app with the new Docker container or with the new Docker image. Okay. So from there, you can make this commit. And when you push the commit, if you go to the actions on your repository, you'll see that there's a new item here. And you can click the job, and then you can see it doing all the different work. Okay? And now this is going to take a minute, but after this image builds, it will then update your Azure deployment with the new Docker image. And then you should be good to go. And so once it's up and running, although I think I broke my deployment already. Did I break it? I think I did. Where is the, yeah. Oh, crap. Oh, no. Oh, no. Let's see which is going to be faster, the build or the... Which is going to be faster, the build or the Terraform? Oh, no, the build was faster. Shit. Yeah, it should still be fine. But basically, oh, hey, it worked. So now, it's actually going to take a long time because what happens is Azure must go and pull the image and then has to deploy it. So this is actually going to take a few minutes. Yeah, it's going to hit an application error. But if you go to the deployment center, Gesundheit. And you go to logs, it's going to take a minute. But yeah, you'll see that it's actually extracting the Docker image that it pulled. Except my shit is broken. Yeah, because I did my Terraform update after. Yeah, so I didn't give it the credentials to log into. Oops. Okay. So you have to do the Terraform first before you do your push. Otherwise, the web app will not have the credentials to go ahead and pull the image. So if you did end up running them out of order, it's no problem. What you can do is you can run the Terraform apply. And then once that is done, you can go back to the workflow and you can just rerun the workflow. Eventually, because Azure is a bit slow. All right, so who's still having Terraform problems? Is it everyone? No? Yeah? Okay. Tell you what, after lunch, let's take some time to mess with the Terraform stuff again and get it working, okay? But in any case, if you update your code to this version of stuff, everything should be fine. and I will push a new version, a complete version of the repository. You can fork it if you like, and then make sure to change your app name and your container registry name and all that. And it should just work. The problem is the Terraform state is pretty funky. So after lunch, during discussion time, we can try to get everyone's Terraform working again. Sound good? Cool. All right, so any questions about the GitHub workflow side of things, not the Terraform stuff, because I want to stay focused. Oh, great. Let's actually re-trigger this. Rerun all jobs. Yes. And then by the time we get back from lunch, the web server should be deployed. So yeah, any questions about this GitHub Actions workflow and how it works? Yes.
So if we do this kind of processes in our own project and if everything works, if we visit that web link that Andrew gives, we see our project, right?
Correct. Yeah. So if you once you have the Terraform deployed, and then once you run this GitHub Actions workflow, it should build your Docker image for your project, push it to the Azure Container Registry, then tell Azure, hey, have the web app pull that image from the registry, and then deploy it. Now, what does your web application, or what does your backend server rely on? Yes, but we're running Docker already. So what other system does your backend server rely on? Hint, look at your Docker Compose. What was that? Database. Did we deploy a database on Azure? No. Okay. So if you try to actually do any of the API operations, it's going to fail. Okay. But you can visit the documentation page. The documentation page does render. I was actually hoping to show you because that's the really cool, exciting part. You're like, oh my God, it's working. And then you can like send the link to your mom and you can be like, I made this. And she's like, what the hell is it? You're like, just be proud of me. Okay. I don't think it's going to be, oh, maybe it'll be deployed by now. Let's see. Yeah, it's going to take too long to refresh. Let's just try it. Yeah, that's not looking good. It's probably still deploying because the deployment takes a little while. Because when we built our Docker image, we were not very efficient about it. Really, you should be using Alpine for most things because Alpine is like super tiny. But we just use the default Python image, and that thing is big. It's like a 1.2 or 1.6 gig image, which is absolutely absurd. If we used Alpine, it would be like less than 500 megabytes probably. But we didn't do that. So yeah, deployment takes a while. Yeah, but eventually, once the stuff is working, you should be able to go to your web page here, slap a /docs at the end, and you should see your Fast API documentation page. But mine is still deploying. Yeah. And because there we go. Yeah. Yeah, it's still extracting the Docker image, so it hasn't finished deploying yet. But by the time we get back from lunch, you should be able to see it. Yeah. So let's go ahead and let me check the schedule again, because I've eaten way too much of your lunchtime, guys. I'm sorry. All right, let's come back by 2 p.m. What we will do is we'll cut the coffee and discussion short, okay? We'll cut it down by half. So that'll go, and I'll update the public schedule. So let's say lunch starts at like 12:30. And then